Hello everyone. Today's topic is stereoselectivity of cyclohexane and epoxide. This is one of the most important topics if we talk about competitive exams like CSIR NET, GATE, to determine the structure of nucleophile, how nucleophile will attack to the cyclohexane or epoxide. It can be easily predicted from today's topic. Okay, so please stay tuned it. So this is cyclohexane in planar form, and this is how it looks like when it is in 3D form. You can see the two conformations which are easily interconversible because the energy barrier, or you can say the energy gap, is very small, almost 22 kg per mole. So these are easily interconversible, and this structure is called flattened chair or half chair. The hydrogens are not exactly pseudo or in axial position. It is basically, this is specially pseudo axial. This is not exactly axial, this is pseudo-axial, and this pseudo-equatorial. And similarly, this is also called pseudo-equatorial, and this is pseudo-axial. Okay. Now coming to the point, when nucleophile attacks, what is the stereochemistry? You can see here is a double bond, sp2 carbon, where nucleophile will add or it will attack to the electrophile. I am approaching with the nucleophile. Okay, there is two paths. Nucleophile can add here, that is path A, and nucleophile add from this side, from bottom side, that is path B. So which is more feasible? We have to understand it. If the nucleophile comes from the above side, that is path A, the transition state will be like twist boat. And if the nucleophile comes from the below side, the transition state will be like chair. You can see the difference. And obviously you know the stability of this cyclic chair is quite high rather than this twist boat like TS. So this path, that is when nucleophile coming from the bottom in this conformation, is very feasible. And if we talk about this conformation, the concept is quite similar. In this case, the nucleophile will come from above side, because if it comes from above side, then it will go through the chair like TS. And in this case, if the nucleophile comes from the below side, it will go through the half chair, not half chair, twist boat like TS. So the transition state will be less stable. So this is not the feasible way. Okay, I hope we have understood it. Now coming to one problem. You can see this is Gilsman reagent is given, and one alpha beta unsaturated carbonyl is there. So basically methyl will attack here, one for addition will occur, and you can easily predict the product. You can expect the product that methyl will be here at the below position, because tertiary butyl is a quite bulky group. So it will place the methyl at the below to avoid the steric. But the expected product is not correct here. The right product is this. Methyl will be above. So to predict this product, we have to understand the transition state and the mechanism, how it looks like. Okay, so stay tuned it. I am showing you the mechanism. So this is cyclohexane in half chair form if we numbering it 1 2 3 4, so tarbutyl is at the 4th position. Okay, and this is carbonyl. If you make it 1, then 1 2 3, and this is 4. Yeah, here you can see tarbutyl group is at equatorial position because it is bulky. It cannot be placed at the axial. You might be thinking that why I am writing this type of conformation. Why? You will understand later it. Okay. So nucleophile, that is methyl, will come and attack here. So you can see the stereochemistry. Here tarbutyl is at above position and methyl will also come from the above. If it comes from the above, it will go through the most stable TS, that is CSIR TS. So the product obviously it would be this. And the question is why I am drawing this type of conformation. I can draw this like, okay. So this is basically 1 2 3 4. You can see the difference. Here it is in the above position, so to make it above, we have to place it at the CO2 axial position, which is quite unstable. So it is basically conformationally locked structure. This is called locked structure. It cannot be converted to this because if it comes here, so tarbutyl group will be at the CO2 axial position, which is quite unstable. So this conformation is right and methyl will above from this side, so we get this product. Okay, this is the product. Now coming to the behavior of the epoxide. The behavior of the epoxides when nucleophile adds is quite similar, is almost similar to that of the cyclohexane. See that it is the structure of epoxide when epoxide is at the above position, like this is. Okay, and this is where below epoxide, where you can see the oxygen is down the group. Yeah, this is the structure. So the behavior, what I have told you, the behavior is similar to that of the cyclohexane. The preferable position of the approaching nucleophile will be that where it will go through the most stable TS, that is CSIR TS. Okay. To applying this concept, we predict the product. This is the question. This is two problems, very interesting problems. Here you can see that epoxide is there, so you can say that nucleophile, that is N3 minus, will attack from the below side. But what is the position, this or this? To predict this, we have to draw the transition state. Okay, I am drawing the transition state. Okay, this is epoxide. If you numbering it 1 2 3 4, that is 3 4. One, two, 3, 6, 5, 6. So you can see that this is not the right conformation because here pH is at the axial position, so we have to change it. Yeah, okay, this is the structure. Here pH at the axial position, not axial position, equatorial position, which is stable rather than this. So this is the exact conformation. So N3 minus is there, it is nucleophile, so it will attack where? Because this is epoxide at the above position, so it is confirmed that nucleophile will attack from the below side, but which position? Because there is two position is available. Okay, A and B. If it attacks from the A position, it is more feasible because it will go through the chair like TS. So this is the preferred pathway, and the product will be this is nitrogen, here pH, this is 6, and you can see the nucleophile attack at the 3 position. Okay, it is 1, 2, 3. So this is N3, CSOH. Yeah, this is the right answer. And similarly, in this case, this will also happen. I am drawing this. I am drawing this side of the page. Here each pH is below. Okay, this is epoxide, pH. Oh, sorry. The epoxide is at the below side. So you can see there is two position, this and this, 1, 2, 3 and 4, 3 or 4, between 3 and 4, N3 minus will attack from 4 position, because it is confirmed that epoxide is at below, so it will attack from the above side. So which is more feasible? If it attacks at the 4 side from above position, then it will go through the chair like TS. That is more stable. So it will attack from 4 side, and the expected product will be this will be below and this will be above. Okay, 1, 2, 3, 4. Okay, so this is the product. Okay, and one more question is also there. The first step is very common to us. It will imine formation will also happen. Yeah, this is very common. Then it is given as NPRI 2 and one is in place of H plus and H2. So what will happen? This is NPRI SO2 will occur, you can predict. Here nitrogen lone pair will come and this will attack at PR. Okay. So you can easily predict, but we have to predict through this way what I told. So the product will be, after hydrolysis, then it will be keto. That is trans product. So this is the product.